introduce you our effort about the monitoring of toxic chemical and biological compound that we are developing during these 3 years of work together with the different units that you can read here. And I mean, it has been already introduced that the monitoring, the extensive monitoring of the seawater is crucial, and that we have to, to face different problems. But in this talk, I will just discuss with you how we want to measure the so-called and want to monitor the so-called emerging pollutants, which are molecules and compounds, toxic compounds, which are very present at very low concentration. The current technology and current methods are not good because we have to face with a lot of problems like lab-intensive measurement, expensive measurement. Generally, these measurements are ex situ, so we have to take the molecule and we have to go out. We need specialized worker and manual handling, and so we have to find other opportunities. We have to find other way for cost-effective monitoring. We have to develop practical methods, easy to use. We need real-time sampling, in situ monitoring, and at least we have to reduce the manpower to achieve good results. And that's what we want to do with our project. We want to develop an automatic buoy that is able to sample and analyze seawater, and then to collect the data, transfer this data to an internet connection. This internet connection will be able to transfer the data to an open database that have to be accessible to the end users. These end users like people on the coastal guard and so on. And this is the schematic representation of our buoy we are working on. We have 2 modules, an analysis module and a sampling and pre-concentration module integrated in the same box. The idea is that in the analysis module we have to perform and we have to develop new biosensing and sensor technology, and the sampling and pre-concentration module have to be integrated. These are the chemicals and the biological pollutants we want to monitor. We identified a specific class of compounds that are indicators like marine algal toxin, chemical compounds like pesticides, herbicides, and so on, toxic algae species, and sulfonamides. And we developed different kind of sensor and biosensing, and in principle we just adapted this technology for the field use, and that's what we are working in the last 3 years. It is in the phase 1 of the project. Now we have to integrate this in the field use, and then we have to validate it in the laboratory and field test. The main important sensor, I just want to give you an overview about what we developed and what we try to upgrade during the last 3 years. This is a representation of the detection of oxalic acid through a colorimetric assay, which is very easy, and the sensing technology is robust, and as you can read, we got good results in terms of sensitivity, specificity, and that automatized measurement has been performed in 1 hour, so we can repeat during the day more than 1, 3, 4 measurements per day. With the same approach, we also demonstrate that it's possible to detect sulfonamides, classes of compounds in seawater, with a simple pre-concentration step and the quantification through the addition of a reagent solution that is able to give us a signal, an optical signal. Even in this case, the automatized measurement has been developed, and it takes approximately 1 hour. And even in this case, we've got good results in terms of sensibility and robustness of the sensor system. But we need a pre-concentration step, and then we will discuss with you this point, which is crucial for our technology. We also are able to measure the presence of marine algae toxin using these molecular approaches that have been introduced by the talk that was before me. And the big advantages of this technique is a sort of sandwich RNA-based method, which has the big advantage of being specific, so it is able to differentiate between different species. We have also developed some technology which are more complicated and that will be difficult to implement in our buoy, about the detection of flare retardant and biocidal compounds, because in this case we have more problems, but we got good results in terms of sensing technology using photoluminescence assay. Then we had to develop sampling and pre-concentration device. This is a crucial point because the concentration of this compound in the environmental level and also in the limit of law are very low. And so we just using our sensing technology, we are not able to detect this compound in seawater, even in coastal buoy. And so we had to, try the way to implement, to combine the sensing technology and the pre-concentration step. As you can read there, the concentration are very low in environmental levels. And so this is very important, and then we had to couple this module with the automatic measurement prototype that we have been working during these 3 years. Here you can see some pictorial sketch of this module, which is a compact module that allowed measurement of multiple targets in the same box. So in the same box we can measure at least two different targets using this reagent area connected with the hydraulics and the optical detector, all fully integrated in this compact block. And then obviously we are also starting to work at the end of the 3rd year to the management of the data and the integrated monitor system. And I'm not an expert about that because I work on the sensing technology, but what I can say is that we are working on the wireless connection between the buoy and the base station. We are we are going to develop an open database which is accessible to the end user, and want to implement the system with this REST API for data collection and system management. And that's it.